Right, got myself some tungsten carbide, 10mm, just to do some tests with. Now, the price of this stuff, it wouldn't be viable to use it. It's just something to satisfy my obsession with stuff like this, because there's 20 balls there for what I paid for them. For what I paid for them 3 little 20 tungsten carbide balls there, 10mm. I could have bought 3 boxes of shotgun cartridges. That's how dear it is for a bloody ball, but it is tungsten carbide. So unless you're a multi-millionaire, I wouldn't be bothered blinking with this stuff. This is, again, it's all about my obsession with density and energy. Because one of these, you can really feel it when you pick them up. Look, it's only 10mm, but that comes in at 100 and just over 124 grains in weight. When you think we compare that to steel, a 10mm steel ball only weighs 61, and a 10mm lead weighs 96 grains. So it shows you how much denser tungsten carbide is to lead and steel. Also, I think it's about 3 times harder than steel, which don't really come into it, but it's the density I'm interested in. I've tried some various setups and that, and without, I'm not one for sodding about with tapers and that too much, and that I'm getting good results with this old setup. These have been on here for ages. A straight cut TheraBand at 20mm straight cut, doubled up. I'm getting an average of 220, if I give it a long draw, 220 feet per second with that 10mm tungsten carbide, which is giving an energy of just over 13 foot-pound. I think it was 13 point something foot-pound. It was between 13 and 13.5 foot-pound. So what I'm going to do now is go out in the garden, and I've got a builder's bucket full of water, and I've got a 4-point, or is it a 2-point milk crate carton behind that full of water. Water is great for slowing projectiles down and sort of getting the distance of, you know, how far they're pushing. Ballistic gel would be better, but I ain't got none. So the whole point of this is, where this 10mm is actually heavier than an 11mm lead. It's actually heavier than an 11mm lead. We want to get the force from this going down onto a finer point. This is how you get penetration. You've got blunt force trauma and penetration. This is like this heavy blade on this knife here, and then as it narrows down to a point, the point is force multiplied. You wouldn't need a lot of force to push that into something. So what you want is the heaviest projectile with the narrowest width to multiply that force onto that point to obviously break a surface and penetrate. That's what you want. You've got blunt force trauma and penetration. Hopefully with this you've got a little bit of both. Anyway, out to the garden. Got an entry there, an exit there, an entry there, and an exit there. So that's about a foot across there, and about another 6 inches across there. So it's penetrated over 18 inches of water at 30 feet. I would have needed more of them, so just shows you the energy that's holding. Again, it's so expensive, but just show you why this stuff's so lethal in shotgun loads. In America they're using it in 410s to great effect, because you can, where it's so dense, you can use a small pellet like a 9, cram it into a 410 cartridge and still get good energy down range, which would be good for the future. But I say it's the price that holds it back. Anyway, I can't be asked to do another test, because it just means more of these. But it just shows you, I thought the bucket would have stopped it. I didn't expect it to, that was a safety precaution. But it just shows you, and that's only at 220 feet per second. Cushy.